This presentation is titled, Magnetron Sputtered Nickel Molybdenum Thin Films for the Hydrogen Evolution Reaction in Alkaline Media, and is based on the study by N.S. Gultham et al., published in Journal of Alloys and Compounds in 2024. Hydrogen is widely regarded as a clean fuel of the future, and one of the most promising ways to produce it is through water electrolysis driven by renewable energy. At the cathode, the key step is the hydrogen evolution reaction. However, in real systems HER is kinetically sluggish, so a significant overpotential must be applied to drive the reaction. Today, platinum-based materials are the benchmark HER catalysts, but their high cost and scarcity motivate the search for low-cost, earth-abundant alternatives. In this paper, the authors systematically evaluated bimetallic nickel-molybdenum thin films as HER electrocatalysts in alkaline solution, prepared by magnetron sputtering from a single custom nickel-molybdenum target. First, molybdenum and nickel powders were mixed to prepare 4 molybdenum to nickel ratios of 1:2, 1:4, 1:6, and 1:8. After dry ball milling, the powders were hot pressed in a 2-inch mold to form dense nickel molybdenum targets, labeled Mn2 to Mn8. These targets were then RF magnetron sputtered onto nickel foam and argon at a power of 50 watts and 200 degrees Celsius for 30 minutes, yielding nickel molybdenum thin films with good adhesion and uniformity for use as HER electrocatalysts. After fabrication, the authors examined the structure and morphology of the sputtered nickel molybdenum films. X-ray diffraction patterns show that all samples retain the face-centered cubic structure of nickel, but the main diffraction peaks gradually shift to lower 2 theta with increasing molybdenum content, indicating that molybdenum atoms are successfully incorporated into the nickel lattice to form solid-solution nickel-molybdenum alloys. Scanning electron microscopy images reveal a compact, nanoparticle-like surface on the nickel-molybdenum films, while cross-sectional transmission electron microscopy confirms a dense film that is well adhered to the substrate. These features are expected to provide a good electrical contact for HER. The authors then evaluated the hydrogen evolution performance of the sputtered films in 1 molar potassium hydroxide solution using a 3-electrode configuration. All nickel-molybdenum solid solution films outperform the single metal electrodes. In particular, the Mn6 sample requires only 39 mV of overpotential to reach 10 mA per square centimeter, and about 172 mV at 100 mA per square centimeter. The Tafel slope of Mn6 is the lowest among all samples, indicating accelerated HER kinetics. Electrochemical impedance spectroscopy further reveals that Mn6 has the smallest charge transfer resistance and the highest double-layer capacitance, corresponding to the largest electrochemically active surface area. These results confirm that sputtered nickel-molybdenum thin films are highly active HER electrocatalysts in alkaline solution. Thank you.